Good day everyone and welcome back to Together and to Infinity's YouTube channel. For today's video, we are going to discuss the definite integral of Riemann sums. But first, we need to know what is the meaning of definite integral.
Riemann sums is a method that is used in order to approximate the total area under a curve by using the combined areas of the rectangles drawn underneath the curve towards the x-axis. There are three possible ways of drawing rectangles underneath the curve. The first is the left Riemann sums, where the upper left corner of the rectangles intersect with the curve, while the second one is the right Riemann sums, where the rectangles intersect with the curve through their upper right corners. Lastly is the midpoint Riemann sums. It is where the midpoint in the upper part of the rectangles intersect with the curve. The fundamental theorem of calculus is a theorem that can help us find or determine the real area under the curve without using the Riemann sums. Definite integral is defined as the limit and summation to find the net area between the function and the x-axis. The definite integral also represents the area under the curve of a function. Now that we know the definition, let us now think of a function with a closed interval. For instance, we have the function f of x equals x cubed minus x squared minus x plus 2 at a closed interval 0, 2 with n equals 8.
First, let us compute the left Riemann sums. First, decide the number of rectangles or n you want to consider. N is equals to 8. Second, determine the step size or delta x. Use the closed interval AB, and AB is equal to 0 and 2. The formula for delta x is equals to b minus a over n. Let us substitute, and it will be 2 minus 0 over 8. 2 minus 0 over 8 will be 1 over 4. Next, determine the partition of point Pn. It should have n plus 1 number of elements. Pn is equals to x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, x sub 6, x sub 7, and x sub 8. And it will be 0, 0.25, 0.50, 0.75, 1, 1.25, 1.50, 1.75, and 2. Next, get the sum of the areas of the rectangles. N sub 1 is equal to f of 0 is equal to 0 raised to 3 minus 0 raised to 2 minus 0 plus 2 is equal to 2. N sub 2 is equal to f of 0.25 is equal to 0.25 raised to 3 minus 0.25 raised to 2 minus 0.25 plus 2 is equal to 109 over 64. N sub 3 is equal to f of 0.50 is equal to 0.50 raised to 3 minus 0.50 raised to 2 minus 0.50 plus 2 is equal to 11 over 8. N sub 4 is equal to f of 0.75 is equal to 0.75 raised to 3 minus 0.75 raised to 2 minus 0.75 plus 2 is equal to 71 over 64. N sub 5 is equal to f of 1 is equal to 1 raised to 3 minus 1 raised to 2 minus 1 plus 2 is equal to 1. N sub 6 is equal to f of 1.25 is equal to 1.25 raised to 3 minus 1.25 raised to 2 minus 1.25 plus 2 is equal to 73 over 64. N sub 7 is equal to f of 1.50 is equal to 1.50 raised to 3 minus 1.50 raised to 2 minus 1.50 plus 2 is equal to 13 over 8. N sub 8 is equal to f of 1.75 is equal to 1.75 raised to 3 minus 1.75 raised to 2 minus 1.75 plus 2 is equal to 163 over 64.
In the left Riemann sums, we can have an alternate solution. The summation from k equals 1 to n of f of x sub k minus 1 times delta x. Here, it shall be known as the summation of from k equals 1 to 8 of f of x sub k minus 1 times delta x equals to f of x sub 0 plus f of x sub 1 up to f of x sub 7 times delta x. This will make the solution ln is equal to the addition of f of x sub 0 plus f of x sub 2 plus f of x sub 3 up to f of x sub 7 times delta x. So the first procedure of this will be f of 0 plus f of 0.25 plus f of 0.50 plus f of 0.75 plus f of 1 plus f of 1.25 plus f of 1.50 plus f of 1.75 all to the power of 1/4. So in the next step, it shall be converted into the sum of 2 plus 109 over 64 plus 11 over 8 plus 71 over 64 plus 1 plus 73 over 64 plus 13 over 8 plus 163 over 64 all to the power of 1/4. So after the sum, this leaves us with half of 25 to the power of 1/4. So the final answer of this will be 25 over 8 or 3.125. For the illustration of the graph, we can use the GeoGebra app. To input values, we can use the d equals the rectangle sum of x cubed minus x squared minus x plus 2 and 0, with 2 using 0. Then the graph will look like this.
For the right Riemann sums, we can have the solution as considering function f of x is equal to x cubed minus x squared minus x plus 2 at ab is equal to 0, 2, n is equal to 8, we can have our equation in the summation form of the summation from k equals 1 to n f quantity x sub k delta x. Substitute the given values to the given variables. The summation from x equals 1 to 8 f quantity x sub k delta x. Then, we have to consider the x sub 1 to x sub 8. F times x sub 1 plus f times x sub 2 plus f times x sub 8 delta x. Rn is equal to f times x sub 1 plus f times x sub 2 plus f times x sub 3 plus f times x sub 8 delta x. Substituting the given values, it will be f times 0.25 plus f times 0.50 plus f times 0.75 plus f times 1 plus f times 1.25 plus f times 1.50 plus f times 1.75 plus f times 2 times 1/4. 109 over 64 plus 11 over 8 plus 71 over 64 plus 1 plus 73 over 64 plus 13 over 8 plus 163 over 64 plus 4 times 1/4. 29 over 2 times 1/4. In decimal form, our right Riemann sums will be 29 over 8 or 3.625. For the illustration of the graph, we can use the GeoGebra app. To input values, we can use the E is equal to rectangle sum quantity x cubed minus x squared minus x plus 20, 2 using 1. The graph will look like this.
To get the midpoint, we need to go back to our partition points to identify the midpoints. We have to get the values of the x sub 0 to x sub 8, which are 0, 0.25, 0.50, and so on and so forth. Getting the midpoints, our equation will be m sub 1, m sub 2, m sub 3, and so on and so forth. Wherein m sub 1 is equal to 0.25 plus 0 over 2, the answer will be 1 over 8. Next is 0.50 plus 0.25 over 2, the answer will be 3 over 8. And next is 0.25 plus 0.50 over 2, the answer will be 5 over 8. And next is 1 plus 0.75 over 2, the answer will be 7 over 8. And the fifth midpoint is 1.25 plus 1 half is equals to 9 over 8. Next is 1.50 plus 1.25 over 2, the answer will be 11 over 8. And the next is 1.75 plus 1.50 over 2, the answer will be 13 over 8. And lastly, 2 plus 1.75 over 2, the answer will be 15 over 8. The midpoints that we got should be equal to n. Therefore, our solution will be m sub 1 is equal to 1 over 8 cubed minus 1 over 8 squared minus 1 over 8 plus 2. The answer will be 953 over 512. Next is the m sub 2, which is 3 over 8 cubed minus 3 over 8 squared minus 3 over 8 plus 2. The answer will be 787 over 512. Next is the m sub 3, which is 5 over 8 cubed minus 5 over 8 squared minus 5 over 8 plus 2. The answer will be 629 over 512. And compute the midpoint just like the m sub 1 to m sub 3.
Using the summation form, we can have the summation of k equals 1 to n of f of m sub k times delta x. By substituting the values, we can get the summation of k equals 1 to 8 of f of m sub k times delta x is equal to the addition of f of m sub 1, f of m sub 2, and f of m sub 3 up to f of m sub 8, all multiplied by delta x. Substituting for the values of m sub 1 to m sub 8, we can get m sub n is equal to the summation of k equals 1 to 4 of f of m sub k times delta x is equal to the sum of f of 1/8 plus f of 3 over 8 plus f of 5 over 8 plus f of 7 over 8 plus f over 9 over 8 plus f of 11 over 8 plus f of 13 over 8 plus f of 15 over 8, all multiplied by 1/4. So in the next step, it shall be converted to 953 over 12 plus 787 over 512 plus 629 over 12 plus 527 over 512 plus 529 over 512 plus 683 over 512 plus 1037 over 512 plus 1639 over 512, all multiplied by 1/4. So this will result in 53 over 4 multiplied by 1/4. Getting the decimal form, we can have 3.3125 as a result.
For the illustration of the graph, we can use the GeoGebra app. To input the values, we can use the A equal rectangle sum quantity x cubed minus x squared minus x plus 2, 0, 2 using 0, and the graph will look like this.
For the last part of our definite integral, we have to get the fundamental theorem, or also known as FTOC. So what you first need to do is get the integral of x raised to 3 minus x raised to 2 minus x plus 2 dx. So we have to solve for the antiderivative of the function, where we can use the formula x raised to n plus 1 all over n plus 1, and then we will have x raised to 4 over 4 minus x raised to 3 over 3 minus x raised to 2 over 2 plus 2x. Now that we have that, we can now substitute the values of the upper limit, which is 2, and the lower limit, which is 0, by using the formula f of b minus f of a. So we will then get 2 raised to 4 over 4 minus 2 raised to 3 over 3 minus 2 raised to 2 over 2 plus 2 multiplied by 2 minus 0 raised to 4 over 4 minus 0 raised to 3 over 3 minus 0 raised to 2 over 2 plus 2 multiplied by 0. And we will then get 4 minus 8 over 3 minus 2 plus 4 minus 0. After we add all of that together, we will get 10 over 3 or 3.33.
Now, let us compare the results. In left Riemann sums, we have 3.125. Round off to 2 decimal places, we have 3.13. In right Riemann sums, we have 3.625. Round off to 2 decimal places, we have 3.63. In midpoint Riemann sums, we got 3.3125, or into 2 decimal places, we have 3.31. Using FTOC, or the fundamental theorem of calculus, we have f of b minus f of a, we have 3.33. We can see in this comparison that in the area derived from the midpoint Riemann sums is the approximation nearest to the real area derived using the FOTC.
And that is all for this video. We hope that you learned something new about the definite integrals. See you in our next video. Bye!